Can you guys hear me?
Yes.
Thank you. All right. Hello, everyone. So let's talk about like a slightly different topic right now. Which is interactive product retrieval challenge. My name is Shizhang, and an applied scientist from Boston. And today, I and Senchang Zhao from our team will present something, some preparation work for this challenge we have been doing. And we have a pretty large team here, and here is basically list all the name here. And don't want to go to the detail. Okay, so today's presentation will cover multiple aspects from the motivation, from to statement, from the challenge itself, for why we need this challenge, and to how we collect the data set to evaluation. All right, let's start with the motivation. I think probably everybody is very familiar with shopping, especially if you have like an extensive life. So, and as we all know, that shopping is not like a very simple grab and go experience. And generally, it's like an interactive process. And basically, you have two or more people. One is the customer, which is ourselves, and the other one is the shopping assistant. And basically, the conversation will start with, for example, the customer say, okay, I want to buy a backpack. And the shopping assistant will, considering the job, the age of the customer, and trying to give a recommendation. For example, for this one, people say, okay, we'll give you this backpack and say, how about this one? And the customer may not be very satisfied with the initial recommendation, and they may have some feedback to share with the assistant. He may say, okay, instead of this black one, I want a red one. And basically the shopping assistant will take this feedback as well as the originally recommended product and give a new recommendation. And this conversation can continue goes on, and the customer may continue to say, okay, can this be smaller? And the shopping assistant say, okay, how about this one with the new recommendation of a smaller bag? So this conversation will continue until the customer is really satisfied with this. Okay, so that is basically a typical shopping experience. And this is actually what we really missing in the online shopping. And where in the online shopping, what we only have is have to borrowing this boring website to find one. So how can we do to bring in this very similar experience to online shopping? So that's actually the problem this presentation is trying to cover. And if we really look into this conversation in detail, we see there is a basic unit inside this conversation. What happened here is that given like a initial product, as well as like a language feedback, and the shopping assistant will trying to get a new recommendation. So that's the basic unit. And this is what we call a single shot interactive product retrieval. And that's actually the problem we're trying to resolve in this challenge. So basically, we're given like a product image, and we call this source image. So here we show like a blue dresses, and as well as language feedback. For example, here is more floral. And basically, the shopping assistant system is trying to come up with a list of recommendation products. For example, here I show 5 here, and only 2 are the right one, and the other are not the correct one. And basically, this recommendation is trying to fulfill the request from the feedback. And that's actually the problem we're trying to resolve in this challenge. Okay, so in order to support the research of this so-called single-shot interactive product retrieval, so we plan to launch a challenge in later this year, or maybe like earlier next year. So within this challenge, we'll launch a new interactive product retrieval data set. So basically, the challenge will contains 2 major phases. So the first one called the training phases, in which the training set will be released for model training and development. And the other one called evaluation, which will release the gallery image and as well as the evaluation data set. And basically the participant will try to upload a ranked list, and our Amazon will try to evaluate the algorithm and report the result. Let's talk a little bit about the data set, and Shen-Qiang will cover that in detail later. So basically the data set will contain 3 subsets. So the first one is called training or development, which is basically 1 million catalog image with noisy label. And in this set, it will contain roughly 100,000 the so-called language feedback between product pairs. And for the Gary set, so we'll also collect like 1 million images, which are new product, which does not cover in the training set, which to simulate the new product situation. And for the evaluation data set, that will contain 10K query image with feedback. This 10K images will overlap with the Gary image. All right. So why this interactive product retrieval is difficult, and how does that differ from this regular product retrieval or product recognition problem? So first of all, the catalog. So basically, we are essentially dealing with like an extremely large catalog. So as we all know, like a typical online retailer may sell like millions of products. And for some like very large retailer, they may sell like thousands of millions of products. And this catalog is not only large, but also diverse. It can come in from not only from fashion, but also from furniture, from consumable, and all of this. And what's more, it's not like a static catalog. It actually keep changing. The new products they're adding with the old product is deleting. So how to deal with this dynamic changing, large and diverse catalog is definitely very challenging. And the second thing, similar as all these other problems, so this is a long tail distribution. So also several products may have a lot of images, but many of the products only have like 1 images. This actually makes collecting information for that product become very difficult, because you only have like 1 image with very little metadata there. Okay. So that's a major difference from this interactive product retrieval with conventional product retrieval or landmark retrieval is this is actually a multimodal problem, which means that's actually the input is 1 image as well as a language feedback. And what we're trying to do is that we need to understand both the image and the language, and also trying to build the relationship between these 2 modalities. On the contrary, the conventional product retrieval only needs to deal with 1 modality. And actually, we have a lot of mutual techniques to deal with 1 modality. For example, the hashing and product quantization. This really help us to deal with this large scale problem. But however, in these cases, we really need to deal with these 2 modality, and how to quickly search within this millions of images, and language feedback is going to be like a very challenging problem, which is still an open question to be answered. Okay, another major difference is the similar products. For example, for the landmark recognition, for the Eiffel Tower, you should only talk like 1 single answer, that is Eiffel Tower. Any other answers we consider to be wrong. But however, for this interactive product retrieval, you really have like multiple answers. For example, here, the source image is a blue dresses, and the feedback is something more floral. And you can imagine there are like probably thousands of images, which is more floral than that. And the below is actually showing another extreme cases, which is showing like a red shot, and the feedback is I want something blue. And you can see basically all this blue shot will fulfill the same requirement. And how to get the best recommendation set to our customer is definitely a new problem we're going to deal with. For example, should I recommend based on the brand, or should I recommend based on the price point, or should I recommend based on different styles? And so that's definitely very interesting problem to discover. And the other challenge is coming from the language feedback. So basically, the language feedback can come in from like multiple directions. For example, they may contain like very simple attributes. For example, coming from color, coming from size, coming from style, the V-neck, the crew neck, or even coming from the price. And those are very simple questions. You can easily find the answer either through the image or through the metadata. However, the customer may ask a more complex question. For example, they may ask for some like abstract attributes. Here gives two examples. The customer may ask, okay, can I have something more formal? For example, the customer wearing that shirt into a ballroom or to join some like very formal situation, or something like more elegant, something like more beautiful, and how to understand this abstract attribute and given like the right recommendation is going to be a difficult problem. And unfortunately, the problem can be even more complex. For example, in real life shopping experience, the customer may ask, okay, can I have something that better fits my body, or can I have something that better matches my charms? So this really asks for the understanding of the context. For the context, it's not only the source image, but also for the customer itself and where he will and what his job and what his position. And unfortunately, our challenge will not cover that situation, but that will definitely a very useful use case in the production. All right, so the final challenge is the multi-turn dialogue. As I just showed previously. So due to the nature of the problem, so the interactive product retrieval is actually a multi-turn dialogue. So the customer will not only give feedback in one turn. So basically the conversation will go on and we have like multiple turns. So what does that mean? So basically the user feedback in the previous conversation may have an impact in current product recommendation. For example, if the customer say, okay, he or she doesn't like the green color, so basically in the future, we shouldn't recommend anything in green. And here gives another example very similar to the previous dialogue. So basically also from the backpack, we give like a black one and the customer say, okay, I like the red one. And the third question is, can I have something smaller? So also this question doesn't contest the red one. So the shopping assistant should be able to understand, okay, the customer is asking for a smaller red backpack, and I shouldn't recommend a smaller black backpack to the customer. But however, how to handle this multi-turn dialogue in machine learning is definitely a new challenge for this problem. All right, let's give the gear to Senchang. Senchang will cover the data collection.
Hi everyone, I'm going to discuss the data collection. So basically, I give you a quick recap about our data set. We plan to collect the three subsets, like training, develop set, gallery set, and evaluation set. So basically, we have already discussed, we have 1 million of images with noisy labels for the training and development side. And there are 100K relative language feedbacks for each of the product pairs. So this side we will use for training and develop our models. And then is gallery set, which is different images from the training set. Is also 1 million images. And for the evaluation, we have 10K query images with feedbacks. So basically, it's like a product retrieval based on this gallery set. So this data set can be used for both the convenient product retrieval and interactive product retrieval. Next slide, I'm going to discuss the training and development side. For this side, there is around 10K source target image triplet. So what I mean by the triplet, it means it will include a source image, target image, and a negative target image. If you look at the right side, so this is what we mean. So basically, the user is required to navigate from the source image, which is product A, to the target image, which is product B, instead of negative target image, which is product C. So this is a triplet. And based on this navigation, so 9 feedbacks will be collected by the worker. So we will hire 3 different workers, and then each of them will write down 3 unique feedbacks. So if you look at it, there are some sample feedbacks provided by the worker. So in a pink, that is shorter, or with a zipped front. And next, I'm going to discuss the evaluation side. There's around like 10K source target images, but here, like we only have like a source image, and but for the target, it's not a triplet. It's just a list of the target images. As we showed earlier, there are for each of the source image, as well as this user feedback. There's more than 1 images which is relevant. So if you look at the right side, so this is how it looks like. So that's the reason we will show a list of the target images. Some of them is relevant, some of them is not relevant. And also we will provide 9 feedbacks as before, like 3 different workers, and each of them will provide 3 unique feedbacks. So yeah, so this is our evaluation side. And for the gallery side, which is, as we said earlier, it's 1 million image. And all this image will be different from the training. And this data set will be used as the index for the retrieval. Basically, you can treat this set as a collection. And all the way we work with the evaluation set. So this collection will be retrieved for the final result, final evaluation. And yeah, and I said this data set will be only used for the evaluation. And here I'm going to talk about the details of our feedback collection. So basically, there are 2 steps. The first step, we will find the related image. And then the second step is we're going to collect the feedback. So for the first step, we sample a source image, and for each of the source image, we find 2 related images. So here we have 3 images. So if you look at the right side, regarding for the source image, which is product A, and the 2 related image, which is product B and product C, we just use the Amazon Mechanical Turk to collect the feedbacks. And we just going to ask the worker a question. If the assistant provide you the product A and you want to buy the product B and the product C, what are you going to say? So here is just some sample. The next slide, I'm going to discuss like details of the feedback collection. So basically, as I said, like we will use the Amazon Mechanical Turk to collect the feedbacks. We set a high requirement for the worker. Basically, they should be located at the US, and also they should have a good history of the data labeling task. So what we call is like a high hit approval rate. Basically, so all the worker is quality enough, and also during this data collection, we also have some validation. So the feedbacks must contain at least 3 tokens. And also like when we provide 3 feedbacks, these 3 feedbacks cannot be the same. So if they cannot validate these 2 criteria, I mean, they cannot submit. So again, like we will, for each of the triplet, we will hire 3 workers. So the red part is just a sample UI. Here, I'm going to discuss the how our data set is relevant from with the previous similar data set. Actually, almost all the previous data set is related to the attribute-based product search. And probably one of them, there's one of the data set is very similar to ours, which called Fashion IQ, and which is based on the conversation. So what I mean by the attribute-based and the conversational-based, so if you look at the red part, I put an example. So attribute search is focused on the attribute and it may be limited because it's always based on a single attribute and more or less an attribute name. But however, a contribute-based search is based on what users say. So as we said earlier, it can be this user utterance can be come from a wide variety of direction. So anything user say is in our feedback. So yeah, the language is complex, which is we need to handle that in our model. In the next slide, so here is we compare the size of the data to the previous data set. So if you can see like both our data set is larger than the previous data set in terms of both the size, the number of images and the number of feedbacks. So yeah, you can see. So this is our data set. Thank you.
Quickly go to the evaluation part. So the major challenges we're facing about the evaluation is actually the problem we are just talking about is the similar product and the answer is not unique. For example, the more flower example, you can basically find thousands of correct answer. And basically, it's not possible to annotate all the thousands of sample from 1 million or few millions of products. So how to deal with that? So actually, we're trying to considering these two different methods for evaluation. So first one is called evaluating a smaller data set, and the other one called pooling. So the first one is actually relatively simple, which basically we are trying to select and annotate a small set, for example, 50 or 200 images. And with that, given like a source image and also the language feedback, we can actually ask to the annotator to annotate each of the images to see if they fulfill the requirement or not. In that cases, we can actually calculate a full MAP within that small data set. And the other one is very popular method using that in information retrieval, which basically called pooling. And basically we get the top K result from all participants, and then we try to pool them. The reason why we got pooled is that because the participant result may have a lot of overlap, trying to pooling them. For example, here we have 6 one, and only 5 one are unique. Trying to find the unique one is trying to reduce the annotation cost. And then we're trying to annotate all these pooled images by yes and no. And after that, we can actually using the precision at K, trying to use the final metric. So it's actually more accurate, but definitely require more annotation cost. Okay, feature work. So definitely one interesting area is trying to using the multi-turn interaction here. So basically here we only deal with singleton, but definitely move to multi-turn should be very interesting. And also trying to deal with user upload images and trying to gap this feature domain is another interesting problem we're going to deal with. All right, I think that's all for our presentation, and happy to take any questions.
I can maybe start with a question.
Sure.
So you said, I think, that the query images, if I'm not mistaken, they will have 9 feedbacks.
Mm-hmm.
And is that kind of multi-round as you described, or just single round?
Oh, that's
is the model expected? Yeah. Go ahead.
That's a single round problem, but basically they provide 3 different attributes to the query, because one single query may be too limited. For example, blue, something like that. So you basically ends up with a lot of similar results. So basically trying to narrow down the answer list, we're trying to input 3 different attributes as a query package.
Got it. So 3 different attributes in 9 different
feedbacks?
Oh, no.
Each, so basically the 9 attributes is coming from 3 different persons, and each annotator will give 3 attributes. So basically, a lot of them
I
will
see.
be similar. We will be manually select 3 like a representative one or 3 unique one. So the reason why we have 3 one is trying to give more diverse result here.
Got it. Thanks.
Any other question? Any question in the chat room? One question is, can we have a slides link to the slides? The answer is yes. I think we will launch all this meeting recording as well as all these slides into the website. So we will, Andrew, we have to have the website, right? All right, if no more questions, maybe we can move to the next